Okay. Is it recording? Good. Let me move this up a little bit. I got the screen here, and I'm going to pause this. Okay, so this is the lesson for today. So basically, we're going to continue with this idea of angle pairs. So in this class, we're going to talk about the angle pairs that exist with parallel. The first thing we're doing is parallel lines. So first of all, in previous class, you talked about parallel lines and the transversal. So let's just talk about that. We can have we can two lines. Either we know like they're parallel, or maybe they meet like this. Regardless, we're going to introduce another line called the transversal. So in this case, the transversal is here. Maybe you recognize it. But in this, we can have a transversal in this set of lines. It looks something like this. So the transversal is a line that crosses two other lines, not at the point of intersection. So parallel lines they're not going to have an intersection, but these lines do. But regardless, these are two transversals. Okay. Now, what we've done in when we cut two lines with a transversal, we create 8 angles. So I'm going to call this 1, 2, 3, 4, 5, 6, 7, 8. And then this over here, we also create 8 angles. They're not, yeah. So this is 1, 2, 3, 4, and here's 5, 6, 7, 8. Now, the next we want to do is something called, we're going to use the word corresponding. Corresponding. Corresponding is simply a fancy word for match. So the idea is I take my hands and I want to put them up together, but let's say like I turn this hand this way. And you say, no, Mr. Adler, that's not how you match up your hands. So you turn around, you say, fine, this thumb matched up with this thumb, this first index matched up with the index, and so on and so forth. And I'm not saying at this point that they're congruent. Yes, they're my hands. The matching fingers are congruent, but you can turn to your partner and hold your hands up and say, okay, my thumb matches up with your thumb, but it corresponds, but it's not the same thumb. So the question is, first of all, what corresponds to what? The idea here, we're going to take these 4 angles up here and literally put them on top of these 4 angles down here. Same thing here. We're going to take 1, 2, 3, 4 and put them on top of 5, 6, 7, 8. So we say that angle 1 corresponds to angle 5. We're going to say that angle 2 corresponds to angle 6. Angle 3 corresponds to angle 7. And angle 4 corresponds to angle 8. Same thing over here. 1 matches up with 5. 2 matches up with 6. 3 matches up with 7. And 4 matches up with 8. Please recall, because some of you are thinking, I did not say congruent, I just said matches up. So if 2 lines are parallel, then the corresponding angles are congruent. The corresponding angles are congruent. So, if these 2 lines are parallel, then all these 1 matches up with is congruent to 5, 2 is congruent to 6, 3 is 7, 4 is 8. Because these lines are not parallel, 1 is not congruent to 5. It matches, but we say, you know what? 1 goes with 5, but it's not congruent. 2 goes to 6, it's not congruent. 4 goes with 8, it's not congruent. And 3 goes to 7, it's not congruent. So you got all these problems. And you say, fine, here's example 1. And I tell you, you're looking for these symbols, you're looking for these funny little symbols, and it says, oh, these lines are parallel. And the next thing what I'm going to do is I'm going to give you one of these angles. I'm going to say this angle up here is 140 degrees. And I'm going to ask you to fill in everything else. Well, you're going to say, okay, well, if this angle up here is 140, this angle down here is 140 because corresponding angles are, if two lines are parallel, then the corresponding angles are congruent. Well, can we fill in other angles? Yeah. You might say, hey, Mr. Adler, this angle over here is 140 because of vertical angles. You might say this angle over you might say this angle over here is 40 degrees because these two angles make up a linear pair. And then you might say, Mr. Adler, this angle here is 40 because these two angles are vertical angles. Then I might say, well, what about the three remaining angles down here? And you say, that's no problem, Mr. Adler, because these lines are parallel. Everything up here is congruent to everything down here. So you have 140, 40, 140, and 40. Okay, now you might have learned some other terms and see other pairs of angles. So first, before we get to the terms, and some of you might be familiar with them. For example, some of you might know the words alternate interior angles, but let's take a look at this. So let's go back here. So if we have two parallel lines, we create two regions. We have a region, this is called the interior, and when we create two parallel lines, we create like a region on the outside up here and down here, and we're going to call this the exterior. And what some of you might notice is that angle 40 here is congruent to this angle 40 here. We call these pairs, these are known as alternate interior angles. So if we use the numbers we did over here, we would say that angle 4 is congruent to angle 6, and angle 3 is congruent to angle 5. So these are other connections you can make. If someone says, why is angle 4 congruent to 6? You say, oh, they're all, because the lines are parallel, the alternate interior angles are congruent. Now, we also notice when we're looking at the exteriors that this 140 is congruent to this 140 over here. And it turns out that those are known as alternate exterior angles. And so we see that the 140, angle 1 is congruent to angle 7, and we also see that angle 2 is congruent to angle 8. That's another pair so once again, you can quickly fill in a chart like this. Another thing you might notice is that if lines are parallel, consecutive angles on the same side are supplementary. It's not a coincidence here that 4 plus 5 equals 180 and 3 plus 6 equals 180. So we can also say, where's my black pen? So another relationship is that this 140 plus 40 equals 180. So same side, interior, or exterior angles are supplementary. And so let's take our numbers. 4 plus 5 equals 180 degrees. I'm sorry, angle 4 plus angle 5. And it's actually the measurement. What's another thing? We can say that angle 3 plus angle 6 is also equal to 180 degrees. Now we can take a look at the exteriors on the same side of the transversal, 1 and 8. So So angle 1 plus angle 8 equals 180. And angle 2 plus angle 7 equals 180 degrees. Now, once again, so we have all these relationships you can use. You know, all these relationships to use. So just get the parallel lines and just figure out and just move through it. Once again, you have to make sure these lines are parallel. The second you see parallel lines and a transversal, you're in luck. Okay, good. Let's move on. And so let's take a look at a problem. I like this last one. I'm going to keep this up. Let's say that, you know, angle 4, well, let's say we got a diagram that looks like this. Looks something like this, and we're told that these lines are parallel, and we're told that this angle up here is a, let's say it's a, you know, 20 degrees. Now you look at this diagram and you say, well, that doesn't, I mean, I'm told those lines are parallel, but how do I deal with it? My suggestion is create this. So just expand it out a little bit like this, expand this out like this, and then write the transversal, and then suddenly you have your diagram that looks like this, and you say, I'm asking you to, let's find this, find x. So immediately you can see, oh, this is the same side. Sorry about that. So 20 plus x equals 180, x equals 160. Good. Or you can fill everything in and get to 160, but the idea is you have two parallel lines and a transversal, you can just fill everything. It looks like the chart you know. Good. Okay. Next. Well, the great thing about this parallel lines is that it allows us to prove that the angles of a triangle equal 180 degrees. So let's just quickly do this. So proof, sum of angles of a triangle equal 180 degrees. You don't have to repeat this proof. I'm just going to show you quickly. Draw two parallel lines, and then draw a transversal, and then draw in a triangle here, the last side's triangle. The question is, does A plus B plus C equal 100? So the question is, what is A plus B plus C? As I said before, I'm just showing you the proof. You don't need to know this. So the first thing is, I told you these lines are parallel. So that means if this is A, that means this angle here is A. All right, because why? Because these are alternate interior angles. I also told you that angle C, well, if this is angle C, we have the third side of the triangle, and you can say, Mr. Adler, can we just extend this? The answer is absolutely. So you know what? If this angle here is C, this angle here is C. Well, the last thing you should notice is, hey, Mr. Adler, you just made like a linear, three angles that make up a line. So that means that A plus B plus C equals 180 degrees. This is the proof that the sum of the angles of a triangle equal 180 degrees. Nice. Next thing. So, and then the sum of the angles are 180 degrees. Just a small little thing. If we have a quadrilateral, let's take any quadrilateral here. A, B, C, D. It turns out that the sum is 360 degrees. Now, we're not going to talk about quadrilaterals yet, but I want to talk about one specific quadrilateral. Let's talk about the parallelogram. The parallelogram. What's special about the parallelogram? The parallelogram has the opposite sides are parallel. Opposite sides are parallel. So it looks something like this. You know, this is parallel to this, and this side is parallel to this side. Well, if you think about this, and so the question might be, this is a parallelogram, and you're told this angle down here is 100 degrees. And the question might be, find the other angles. Find the other, this is Y, and this is Z. Well, you're in luck, because if you have a parallelogram, you have parallel sides. I'm going to make this look like that. So first what I'm going to do is extend this out and do my transversal. And you say, oh, Mr. Rather, these angles are the same side. That means if this is 100, this is 80. Now the question may be, well, Mr. Rather, how do we find these? Well, it's very basic, because you know what? To take a different perspective, maybe turn your paper and you say, you know what? These are the new parallel lines. And these are the new transversals. Which means if this is 80, this is 100. And if this is 100, this is 80. And that's the idea of, so once you take your parallelogram, you immediately turn this parallelogram into this diagram with your parallel lines and your transversals. Good. Last thing I want to talk about in this video is, this idea of extending lines. It also applies to triangles. So the idea is, I want to talk about exterior angles. Exterior angle. I'm not going to write a definition down. I'm just going to describe it. So you draw a triangle, any triangle. So we have A, B, and C. What I'm going to ask you to do is extend side AC, starting from A, and move out towards C to D. So I put my pen on A, and I go to C, and I continue to extend this way, and let's make this point D. So this technically is really Ray AD, but that's not important. What I've done is extended the angle. Now, at the extended the side. What I've done is I've created here, this is known as the exterior angle. So angle B, C, D. Actually, it's kind of funny. In GeoGebra, they would say DCB. So let's do that. DCB is an exterior angle. And to save time, I'm just going to tell you, it's actually equal to the two interiors is equal to angle A plus angle B. You can prove that. Maybe you can try that on your own. Try that on your own to show that angle DCB is congruent to angle A plus angle B. But let's just do two examples. So here's a triangle, and you're told that this is an extended angle. You're told that angle A is 50 degrees. You're told that angle B is 70 degrees. This is C, and this is D. And you're asked to find angle DCB. And you say, okay, well, DCB is the exterior angle. Therefore, it's equal to 50 plus 70, which is equal to 120 degrees. Maybe I might mix it up a little bit. I gave you another triangle. Here's A, B, C. I'm going to extend A through C. I'm going to tell you that this angle A is 60 degrees, and angle DCB is 150 degrees. And the question is, find angle B. And you say, no problem, Mr. Rather, because the two remote interiors, so this is angle A plus angle B is equal to angle DCB. 60 plus, let's call it X, equals 150, X equals 90 degrees. And now you're able to do the rest of the problems on the sheet. Good. Can you see the board? Good.